Yes, by default, and I'm going to write at the beginning of the midterm this. Yes, unless I say otherwise, yes. Good. Okay. So let's continue on what we started. So is there any other question? If you don't have question, there is no need to talk, right? Okay. So we already discussed this before, but just a quick refresh for your mind. We said the main benefit or the main mentality or the main mindset of OOB is now we define things as entities, which what we call objects, right? And the good thing about those objects, if you compare them to non-OOB languages like C, for example, is it's closer to the reality, right? So you can define things as entities that have some features and some behavior and some action, right? So we have, and this allows you to, first of all, easier model the real world, and the second thing is you are able to reuse your code, because if you define everything as modular code, later you can use, for example, assume there is a program that you just write in C, there are no classes, nothing, right? You can still write functions, but it's just an intermediate step. But then in Java or any other OOB like C++, you factorize your program into 100 classes. Every single class of those you can actually reuse in other programs if you define them in a good way, right? In a good programming skill. So each class is an entity or a module that you can plug in later in different programs, right? In another version of your program, in a completely different program, right? So you can still reuse part of your code. If everything is just behavioral or sequential, there is no classes, nothing that is kind of modular, you will not be able to do so, because you have to go through all the code, take part of it, make sure this is a very hard task, so no one does this, right? So this is another benefit of OOB, which we discussed earlier, that you are able to upgrade or reuse your code. Good? And then here is a funny example about how OOB can model the real world, right? We said, assume that you have a dog, right? And then you can actually think of this dog as an object, right? And this object can have some attributes which will be mapped into our instance variables, right? Like global variables, for example, or private ones. And then something like the fur color, the weight, the shape, like any other thing that you think of an attribute of a dog can be an instance variable, right? On the other hand, the dog or the object in general takes some actions, does something, right? And this is modeled as a method in OOB or a function, right? In Java, we call these methods. So a dog can run, can eat, can bark. And then invoking a method in OOB, in the real world, it's like asking your object, or in this case, your dog, to do something, right? Something like saying, if your dog has a name of Rex, then you can say, Rex, do run. Running, right? Something. The main message, this funny example, is using OOB, you are able to faithfully model the real world as easy as possible. You can still implement these things in C as well without OOB, right? But the main difference is now in OOB, because we don't have classes, you don't differentiate between attributes and actions, right? You don't differentiate between a dog color and its own method that is running, its action as running, barking, doing something else, right? In OOB, these are completely separate things. Methods or actions can use attributes, right? But they are interacting with each other in a certain clear way. In C, everything is blended, right? You don't have methods, you don't have classes. You can still have functions, but functions take variables as input, and you define the variables of a function inside the function itself. Everything is mixed, right? So in OOB, you have the advantage of being able to model the real world in a better way. Good? Last time we also discussed this topic, which is the difference between instance fields and methods and static fields and methods. Can someone remind me of what is the main difference between an instance variable, for example, and a static variable? Yeah? Yeah? This is one clear difference, is that static is independent, what you wanted to say is independent of the object. It's the same for all objects because it's related to the class itself, not the objects of the class, right? And then instance variables or instance methods, they are defined per object, right? So every object will have its own version or own memory location of that variable or of that method. Good? Another difference? Another important difference that comes from this difference about its duration in memory, right? Static variables and methods exist in the memory once you just define this class, independent of whether you define objects of that class or not, right? And this comes from the same thing in C. Once you define a static variable, it exists in the memory during the execution of the program. We know this from C, right? The same thing in Java. Once you define a static variable or static method, it exists in memory the moment that you define the class, independent of whether you instantiated this class with objects or not, right? And it's one memory location for all objects. Good? Okay. And then based on this differentiation between both, we said you should define a variable or a method as an instance if you know it's independent of the object. And in previous lecture, we had this example of you have a class that is called point that has x and y coordinates for a plane, for example, right? And then we define a static variable that we call count because we wanted to count how many times we calculate points or location of a plane, right, during a flight. And then we said this is independent of the objects or these times, that each time we do the calculation, we want to count the objects themselves. This is why we define the count as a static variable, and each time we increase it by 1. On the other hand, x and y are instance variables because x and y will change from object to object. Good? Okay, so recall that we had this class last time. What I want you to do is to open, whether you have NetBeans or you open like the online Java compiler from tutorials point, and write down this class because we are going to do things on it. So I'll give you 2 minutes to just copy this. You already have the slides, you can even just copy and paste it in the online compiler. How many of you are not able yet to get NetBeans working on their laptops, on their machines? So not many. So for those, if you don't have NetBeans, you just open an online compiler, either online GDB, or if it has issues, you can just Google online Java compiler. It will give you the tutorials point one, which is like a pretty good one. Maybe I just help you here. Okay, so you guys can use this one if you have problems with the laptop. It's tutorialspoint.com/compiler Java something. I don't see from here. So you already have the slides on Avenue. You don't need to take pictures or write anything. You already have the slides up there. Okay. Good? So let's see what we'll be doing with this. So the last time we have already done this. We already defined the static variable count, and then we did a static method that is called getCount. It just returns the count variable. And then this is a constructor that takes 2 points x and y, not 2 points, 2 coordinates x and y, and then set our local x and y to this using the set method, and then increase the count by 1. Good? What we want to do, right? So we want to write an instance method that does a scaling for the boy. What do we mean by scaling? Assume I want to, like the same example of a plane during a flight, and then I want to scale the point that I am in based on that is showing the point on the map, right? If you have a small screen, then your x and y coordinates would be different than if you have a big screen. So you need to write a scaling function, which the only thing that it does, very simple thing, it just takes x and y and then multiply them by a factor, right? So let's look into what we want to do one by one. The first thing is whether this should be an instance method or a static method. Good? This is operating on x and y. X and y are instance variables. So here the judgment is very clear. This should be an instance method because you are dealing on instance variables. So this shouldn't be static because it's now on the object. Good. And then we will declare a method called scale during the class itself. And what do we want to take as an input? What do you think? What will the scale do? As I said, it will take x and y and then multiply them by a factor. Good. What inputs I need to use? Yeah? Yeah, good. So I need my scaling factor, but I also need other things. I need x and y, right? But should I take x and y as an input parameter or not? No, right? Because x and y are instance variables of the same class, and we have access to them as a method within the same class, right? So remember, this is also something good about OOP. If you define a method inside a class, an entity, it has access to its own attributes or instance variables. So now we don't need to pass x and y as an input parameters to this function. In C, we would do completely a different thing. We would have to pass x and y because there is no connection between x and y and the method in this case, in the C language, right? But in Java, given that both are on the same class, then they have access to each other, right? And then the other thing is, do I need to return a value from the scale method or not? What I'm doing here, I'm multiplying x and y with a certain factor. The change should reflect directly on x and y. So that means I don't need to return anything, right? In an enhanced version, maybe you return a Boolean variable that says whether the scaling has been done already or not. Because, for example, something you can do in a function is to say, I'm going to scale but within certain limit. For example, I'm not going to scale beyond 1,000. So you need to do a checking at the beginning that your scaling factor is less than 1,000, right? Or, for example, your scaling factor shouldn't be negative. Something of that sort. So if you have such thing, a good programming skill that actually, but this is beyond this example, is people usually avoid returning void from any method, right? What they do instead, if you don't want to return anything, they just return a Boolean variable that say whether the operation of the method has been done or not. Why this is the case? Because you can allocate memory within a method and maybe this will not succeed, especially in C. Or you can perform a certain checking variable and based on this, you execute your method or not, similar to the example that I just gave you, scaling given that the scale factor is less than 1,000. And that means there are cases where the scaling will not happen. As a caller for this method, I should know of that, right? I should know, oh, the scaling didn't happen. Then I return a Boolean variable that's saying false if the scaling didn't happen and true if the scaling happened, right? So something just to put in your mind, a good programming skill is always to return a Boolean if you don't have something to return, and this is going to check whether the operation has been done or not. Good? Good. So we already decided our parameters. And then we decide to access this method as public. Why? Because you want users, other classes to be able to scale a certain point. If you are going to use the point class in another class, this method should be generally public. A good programming skill also is, or maybe the first thing you think of is, instance variables should be by default private unless you have a different case. So the default case for an instance variable is to be private. On the other hand, the default case for an instance method is public, because you write a function or a method to enable others to use your methods or functions, right? So just take it this way. The default thing for a variable or an instance variable should be private, methods should be public. Unless, this is not a general rule, it's just like the default thing. Unless you have something in mind that intentionally you want to change this. Good. So what you should be doing is you should write your own, maybe if you like, without showing you the code, based on what we discussed. You write the scale method inside the class that you have right now. So write our scale method based on you take an input that is scale factor, you just multiply x and y by this factor, right? Just go ahead and write it. You already have the class written, right? Okay. So what you should have written is this thing. We said you define it as public, and then it takes as an input a scaling factor, and then multiply x and y by this scaling factor, just like that simple, right? Is there any question? Good. Okay. So we want also to write another method. This method is a little bit different, and it has a good thing that I want you to know, right? What we want to do now is to calculate the distance between two different points, right? So you have a point with x and y, another x1, y1, another point x2, y2, and I want to calculate the distance between these 2 points. What do you think is different in this case? What should be done? First of all, let's discuss what are the input parameters to this method. Yeah? Yeah, so first thing that comes in mind is I need x1, y1, x2, y2, which is the point, the first point and the second point, right? But this is the C mentality thing. Think of this is going, if it's going to be an instance method, it's going to be part of a class, right? So it already has access to one of the points, right? So remember that our class is called point, has the attributes x and y. So if I define distance 2 inside that class, that means now you already have access to one of the points, which is the class that you are in, right? Assume this is x1, y1. And then what you need only as an input is the other object, right? Like the other point, right? Is that clear? So what you have right now is you have your own, or this x, this y, but you need another x1, y1. How you pass x2, y2? How would I pass these x2, y2 to the method? Yeah. Exactly. I'm going to pass an object or a pointer to an object of that class, because at the end, it's not x2, y2 that I'm looking for. I'm looking into the class that is called point itself, right? Good. So what I'm going to write here is this, and this is a method that takes as an input, as he said, an object of the class point, which I call that, right? Why do I call that? You can actually call it anything. You shouldn't think that that is a reserved word, right? This is the only thing that is a reserved word, because I mean that is the other class, right? I already have this, and then I need that, right? And then how would I calculate? This is discussing whether it should be instance or static, similar to what we discussed earlier, and we are going to come into this later, right? But then for now, distance 2 is taking that, and we are already within a point class. How should I implement the distance, right? You guys already know from math is a distance between 2 points should be what? Should be Okay, let's forget about this now. What should be the square root of the difference between x plus the difference between squared and then the difference between y squared, right? Yeah. We are going to come into this, right? But for now, you need the difference between x and x1 and x2 and y1 and y2. It's like square rooted, right? So for now, to do this, you are going to define another variable, which is our distance, and then use the math power function. Okay, this is the first time we use this. And then it takes the difference between x subtracted that dot x. What is this x thing? Yeah? Yeah, the current point, which is this dot x. You can also write it as this dot x. So x without anything before it, it means it's the x of this object right now, right? And then you subtract that, and then you do the power 2. Then you do the same thing for y. Because x of that class is actually, this is another object, then you have to do the member, you have to use the member operator. So you have to say that dot x. It's different than this thing, right? And then by doing this, and then you have to take the square root, right? And then this will be your distance to this class, right? It's like you are standing in a certain point and you say, my distance as a point from the other point is this, right? This makes sense? Is there any question? Good. So now comes his question is, should I, for the math functions or methods, should I include anything? The answer is no, because the math class or the full math library is part of actually the Java language, so it gets included by default. So you don't need to include anything. Good? It's just right in here. So now I have another question, which is now we declare this as an instance method. So that means we already assume a certain point and we get the distance to another point. What if I define this as static, right? Which is an attribute of the class itself rather than an object. What should happen in this case? Can I still use exactly the same implementation? This is a very important thing that you guys need to understand. If you define this method as static, what would happen? Can I still use this exactly? If you try this right now, and then you define this as static, then you run the program, would this work? What do you think? Okay. But then what will be different? Good. Yeah. So what is the main problem here, based on what you said? So what your friend said is, by defining this method as static, now it's not related to a certain object, it's related to the class itself. What difference does this make in this body of the method or the function? Yeah. Exactly. You don't have, just doing x and y, you are referring to a certain object. Now, by defining your method as static, you don't have access to these objects, right? Or in another way, you are not associated to a certain object. So you cannot just say x and y. What I would do to get it to work, now you cannot assume a knowledge of this dot x and this dot y, because basically there is no this, right? A static method is not associated with a certain this object, right? So there is no this. That means now I'll go to the old method, which is passing, as he said, passing the two objects as an input. So now instead of passing a certain one point, your static distance to method is independent of a certain point. Remember, by defining this as an instance method, you are standing in a certain point object and you are calculating your distance to another point, right? By defining this as static, it's different. Now you are standing not in a certain point, you are on your own of the class itself, and you have to refer to 2 points, right? So you should take these 2 points as an input and then calculate them, right? So what would be different here is, now you will take point 1 and point 2 as an input, and then What will change is you have to say now point1.x minus point1.x, point2.x, and the same thing for the y, right? I guess this should show you the difference between a static and an instance method. Is there any question? Yeah. No, we had access to the count from the previous example, and we were able to set them during constructors of objects, right? So you can still, the thing is statics are get defined once you run the program from the beginning, but their value can change over time. So static is about their duration in memory, not about their value, right? Static is different than constant, and this is a very important thing. Constant means you don't change this during running time, and then it's only set during compilation, right? But static means you define a variable to be existing in the memory during the runtime, but you can still change its value, right? Is there any other question? Good. Okay, so arrays of objects. So if you think of what we have been doing since C, anything we take as new, we then complement this by defining arrays of it. So we studied pointers and defining arrays of even arrays themselves. We define arrays of arrays, which is 2D arrays, 3D arrays, right? So by just to wrap up objects, you should know that object is nothing other than a data type for now. A class is something like you are defining a data type, and objects of that class are nothing other than variables of this type. As I said before, int x, you can define an array of integers, right? Point class, you can define an array of objects that are instances of the point class, right? So we can define arrays of objects. The way to do this is, it's exactly the same way of defining an array. What do we do here? We say you want an array that is called my array, and then you say it's new to allocate the array size, and then say point 10, which means you define 10 objects of this point thing. One question that I have for you right now, it says that the right side allocates an array of 10 references to point objects. No point object was yet created. Is that true? Because I already used the new reserved word here. Why no objects are being created? I told you before that by just using the word new, you are defining a new object, right? Right now I'm telling you, you already used new, but still no objects are being created. Why this is the case? And this may be for a bonus mark. Yeah. You didn't pass, but I also said, I guess, previous lecture or the lecture before is if you don't pass any elements to the constructor, then it just gets initialized to 0 by default, right? So you don't have to do this. You can still define objects of a class pointer without doing the constructor thing, yeah? No, right? This is not what we said before. Like once you define new, you want to define this object in memory, right? Yeah? This is a very important question. Let's say it again, right? Here, this statement, what I'm saying, what I'm claiming is that they don't define any object yet. They don't create any object yet in memory. But yet, I'm still using the word new. So what is happening here? Yeah? Exactly. This new is not for the objects. This is for the array, right? Remember, we have two different things here. In the array lecture, I told you that array is nothing other than an object in C, and to allocate storage for the array in memory, you have to use the word new. Whether you are creating an array of pointer, like a point, or an array of integers, it doesn't matter. You have to use the word new for that array. This is the new for the array, not the new for the objects, right? So this new is allocating the 10 locations for the array, but didn't create the objects yet. You still have to use the new for the objects. Good? How to do this? You go through element by element in the array, and then until you go to the array length, and then you define here a new object of the pointer by using new point, and then this is the constructor as your friend here was saying. What I'm doing in the constructor here, I'm saying initialize your x by 50 multiplied by a certain math random function, and then y by the same thing. Why I'm doing this? You can initialize it using anything. Here I'm just initializing it with random variables, right? with random values. Math.random returns something between 0 and 1 randomly, right? And then I multiply this by 50. And then I'm returning this because originally random would return a double for yourself, so I'm casting this back to int because x and y are integer values, right? Just initializing x and y values. Good. Is there any question here? Okay. So if I want to modify this to now write a program that does the following. We already initialized an array of 10 objects of class point. Each one of them has its own x and y, right? Now I want to write a code that is using the point class, and what it does, it takes all the 10 objects, calculate the minimum, the class identifies the point with a minimum distance, x and y, from the origin, from 0, right? So previously we had the distance to method, which is between 2 points. Now what I want to calculate is the minimum distance between any point and the origin, right? Among all these 10. Good? So what I'm doing here is I'm defining that a pointer that I call origin, which is 0 and 0. This is my point class, pointing to 0 and 0. And then I want to calculate the minimum distance. So first of all, what I do, I'm going to use my distance2 function, but now I'm going to calculate the distance between my current point and the origin, right? And then this is returning a distance, which is double, taking this as the minimum one. So going through the array elements one by one, each time calculate the distance, and then what I should do later, define a separate variable that I call minimum distance, and then each time compare the new distance with the minimum distance. If it's less, then you exchange them. If not, you update your min. If not, then you keep your min as it is, right? So this is like a very simple trick. You go through the objects, each time you calculate the new distance, compare this with your minimum distance. If it's less than it, that means the new object has like a lesser distance from the origin, then you should update your min. Otherwise, you just keep it as it is. So you say, calculate here the distance to origin for I, and then if it's less than your original dmin, then update dmin. Otherwise, you just continue. Good? Is there any question? Good. So, for now, we're going to have a quiz, and what we're going to do is, using our previous quiz class, which we call student, but I want you to update one thing. I want you to update the courses instance variable to be actually an array of objects from another class that we call courses, right? So what you need to do is use or define another class that you call courses. It has these parameters: name, code, instructor, semester offered, capacity, and then you come up with the types yourself. And then use these courses inside your previously defined student class, because previously the student class had a member that is called courses, but in our previous quiz we had this as an array of strings. Right now it should be an array of objects from the courses class, right? You have 10 minutes for them.